For these first two problems, we're determining whether a set of vectors is linearly independent, which is equivalent. The definition of linear independence is that ax equals 0 has only the trivial solution. So I have taken the three vectors and put them into a matrix and row reduced. And the reason that helps us answer the question is that we can imagine that this is augmented with zeros, because that would be the equation ax equals 0. No matter what row operations you do to get this into RREF form, your augmented column is still going to be zeros. So when I look at this, I can say this does not have only the trivial solution, because x1 plus x3 equals 0 implies as long as x1 equals negative x3, I have a solution, and I'm gonna have infinite solutions here, which is many more than just the trivial solution x1, x2, x3 equals 0. Okay, but in this next one, when I row reduce and imagine that I have augmented with zeros, this says x1 equals 0, x2 equals 0, x3 equals 0. That is the trivial solution, so this is linearly independent. Okay, so now I have some drawing tasks. I want to do any that are possible. Two linearly independent vectors in R2. So that would be two vectors that are not multiples of each other. So they just have to point in different directions. So there's two vectors that are linearly independent. Dependent would be vectors that are multiples of each other, which means they would be point in the same direction and just be different lengths. So I might have this one and this one. Three linearly independent vectors in R2. That's impossible, because if I draw two, I can draw two that point in different directions. But any third one I try to add, I could build as a linear combination of the first two. So like if I pick another one over here, that's actually a linear combination of the two green ones. So this one is impossible. Three linearly independent vectors in R3. So this is three vectors that point in different directions. So I'm just going to point one in the x direction, one in the y direction, one in the z direction. Okay, circle the appropriate response. If a set of vectors is linearly blank, then one of the vectors in the set is in the span of the remaining vectors. That would be dependent. The columns of a matrix A are linearly independent if and only if every row or column has a pivot. So it is every column. That's how you're going to get a unique solution. Like if you look at 2, the reason this is ax equals 0 has only the trivial solution is the x1 equals 0, x2 equals 0, x3 equals 0. It's the pivot in every column. Okay, this last bit is for fill in the blanks. If one vector is a scalar multiple of another vector in a given set, then the set is linearly dependent. If one vector is the difference of two other vectors in a given set, then the set is dependent again, linearly dependent. If each vector in an ordered list of vectors is not in the span of the previous vectors in the list, then the set is independent. Not in the span of the rest of the set, independent. Any set of vectors in Rn containing more than n vectors is linearly dependent. Suppose S is a set of vectors in Rn and there is a vector v in S such that the span of S and the span of S minus that vector are the same set. Then S is dependent. If you can remove a vector and the span is still the same, that means that that vector that you removed was a linear combination of the ones that remain, so it's a dependent set. Is the set 1 0 0 0 1 0 0 0 1 a linearly independent set of vectors from R3? Yes. If you put them in a matrix, it would be in RREF form, and there is a pivot in every column. Must every set of vectors in Rn be either linearly dependent or linearly independent? Yes. Those are the only two options. Let V1 to Vn be a set of vectors in Rm. The set is linearly independent if and only if what equation implies that x1 to xn equals 0. Okay, so it's x1 v1 plus x2 v2 plus dot 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 xn vn equals 0. Putting some weights on those vectors, adding them together. If the only weights that can make that 0 are all zeros, then the set is linearly independent.